Hello, welcome back to Chapter 8, Section 3, where we're adding and subtracting rational expressions. And this is the example that we add to this section that doesn't fall under that. And it's really kind of frustrating, but I understand why they put it there, and I'll explain why too. We're actually dividing, and that was the last section that we did where we did multiplying and dividing. I have this sum, 2 over x plus x over 4, that's being divided by x plus 1 over x. This is what we call a complex fraction. And a little bit of a side note about that. The last time you heard me say complex, sorry, got the hiccups. The last time you heard me say complex was when we were talking about complex numbers. So numbers that, all the numbers that you know are complex, but we brought it up when we had like a plus bi, where I is the imaginary part. That's not what we're talking about here. Okay, so we're using the word complex in a way of saying complicated. This is basically fractions where the numerators and denominators are fractions. We got fractions divided by fractions. And it would be perfectly okay to simplify this by multiplying by the reciprocal like we did in the previous section. The reason why we're bringing it up in this part is because there's another way of doing it. And remember, Algebra 1 and Algebra 2 is all about providing methods, providing tools for more complicated problems down the road. We're setting you up with the language of algebra so that when you make it to calculus, we'll say calculus, you can actually start to solve complicated problems. I kind of look at it like arithmetic is where you learn your letters and how to spell words. In algebra is where we learn how to write sentences, and in calculus is when you learn how to write paragraphs and eventually write novels. So this is just another way of showing a method that might be useful. And later, if you see something like this come up in a more complicated problem, you'll have different skills. The reason why it's connected to this section is because it involves the lowest common denominator. So look at all the denominators of the fractions that are inside the numerator and denominator. So I'm looking at the x, the 4, and the x. Now here's an x, here's an x, so that's a common, but they also have a 4. So I want to do something. I'm going to copy it here real quick. I want to do something that I'm going to multiply the top and the bottom by the same number. That's going to eliminate that denominator. And I gotta be careful. I mean the denominators in the smaller fractions, as opposed to, I'm not going to eliminate the entire denominator. What could that be? Well, both of them have an x, so if I multiply by x, that's going to be eliminated. But I also have to multiply by 4 here, which means I have to multiply by 4 here. And what I'm doing, I'm not including anything new. I'm just multiplying by the number 1. This right here, as you've seen me do this before, is just the number 1. 4x divided by 4x is 1. And of course, I want to point out, we're going to assume that everything's defined because you can't divide by 0. So everything else is going to be okay. All right, so what happens? I'm going to multiply 4x times 2 over x. And I'm using the distributive property in the top. So I'm going to multiply 4x times 2 divided by x, that fraction. And I'm also going to multiply 4x times x over 4. That's distribution. That's all I did. And that works because I have that addition sign right there. I'm adding two fractions. In this one, I'm adding the x plus 1, but I'm not adding two separate fractions. I'm using one denominator. I was going to say it in a different way and I caught myself. So in the denominator, all I have is x plus 1 over x multiplied by 4x. Okay, and as always, pause it, try to trace what I just did, rewind it if you need to. Let's simplify this a little bit more. Now I'm just going to look at this, okay? The x's are going to reduce. You can even think of it, maybe I could have written it like this: 4x over 1 times 2 over x. That would have been the same thing. And I think that sometimes in middle school, when you're learning how to multiply like whole numbers by fractions, sometimes they specifically say just put it over 1. So maybe that reminds you. You don't need to, and that's why I didn't, but it was good for me to remember to say that as I pat myself on the back. So if I look up here, the x divided by x is going to equal 1, and it's going to reduce. So I just get 4 times 2. 4 times 2 is 8. Now for this part, I'll write it again up here: 4x over 1 times x over 4. This time the 4's are going to reduce, and I get x times x, which is x squared. All of this right here just equals 8 plus x squared. In the denominator here, I'll try to squeeze it in up here, I get x plus 1 over x times, put parentheses around there so we know that, 4x over 1. Well, again, the x's are going to reduce. So I get 4 times x plus 4 times 1. 4x plus 4. Now, the last thing I need to do is check to see if I can factor anything. The top is not going to be able to be factored. I can actually rewrite it and put it in best form, but that's not necessary. Best form exists so we can all have the same way of putting it together so we know what it looks like. So if I was giving you like a multiple choice test and you had this, but one of the solutions had this, at least you'll know that that's what that's supposed to be. If it was open-ended or a written test, I'd be okay with either way, unless the directions said differently. 4x plus 4 has a common factor of 4, but nothing's going to cancel. Oh, don't say cancel. And that's all there is to it. So we'll have a couple of these on here just to practice, but again, it's just meant for like a new skill that will help you later down the line.